So in the last session, we were discussing the macromolecular structure, and only three macromolecular structure you have to learn. That is diamond, graphite, and silicon oxide. So you should be able to explain the bonding in diamond, bonding in silicon oxide and graphite, arrangement, how the atoms are arranged in the structure, the properties, how it looks, and what are the uses. So if a question is there, relate their structure to their use. Example, we say graphite can be used as a lubricant and add or a conductor, and diamond can be used for cutting tools. So what is the reason if they say why graphite can be used as a lubricant? The term lubricant means you put between the two surfaces to reduce the friction. So why we can use graphite as a lubricant? Because its layers can slide over each other, or layers can move over each other. So as the layers, like I have two surfaces, two objects, which are placed one over the other. So because of the contact between the surface, what they will have friction. How we can reduce the friction? By putting a oil between them or by lubricating a surface. So how lubrication can be done? One way of lubricating is by putting graphite between the two surfaces. So when we put the graphite between the surface, like example, this is a one layer of a graphite and this is another layer of a graphite. So when we put graphite between the two surfaces, as we apply a force, so when we push the two objects, because the graphite is having a layer structure, so these layers of a graphite can slide over each other, they can slip over each other. So as the layers can slip over each other, the two surfaces can easily move over each other. That is why the graphite can be used as a lubricant. Is it clear? The concept of a lubricant. And the second, it can be used as a conductor. Why it can be used as a conductor? So when you check the previous slide, as we know, it is having free electron in the structure. So if I draw the structure of graphite, a hexagonal ring, so we know carbon belongs to group 4. So as it belongs to group 4, it is having 4 electron in the outermost shell. But what happened in a graphite? Because the carbon is forming only 3 bonds, so one of the electron is free. And this electron can move from one place to another. So due to the movement of electron, it can conduct electricity because there is a free electron available in the structure. As 1 2 3 bonds are there, so there is another free electron. So this electron can travel from one place to another. So graphite can conduct electricity. And diamond, it's the hardest substance known. Because of its structure of rigid structure, it can be used as a cutting tool. Then we should be able to describe the similarities in the properties between diamond and silicon oxide. So how diamond and silicon oxide are similar in their properties? Both are very hard, the diamond and silicon oxide. Both have high melting points. Both are insoluble in water, and both of them does not conduct electricity. Is it clear? The comparison between the diamond and silicon oxide. Because they have the similar structure, that's why they have the similar properties as well. Use of the diamond. The diamond can be used to cut the substance. Why it can be used to cut the substance? Because when you have a diamond is the hardest substance. No, like example, you have an object and you want to cut this object. So what you can do, you can use diamond to cut this object. So when we strike this object by a piece of diamond, this diamond, because it does not show a change in the shape, as it does not show a change in the shape, the other object will deform. All the macromolecules, diamond, graphite and silicon 4 oxide, all are insoluble in water, does not dissolve in water. So if the question is, which statement explain why graphite is used as a lubricant? A, B, C or D? Use the screen annotation to state the answer. Yeah, that's right. D is the correct answer because the layers in the structure can slide over each other. That's why it can be used as a lubricant. Diamond and silicon 4 oxide both have the giant structure. Which statements are correct? A, B, C or D? Look, when you check diamond consists of carbon only. All the carbon atoms are there. Only one type of element. So one type of atom, so it is element only. Diamond is not the compound. Silicon 4 oxide, it consists of silicon and oxygen. When element consists of two or more atoms, we call that as compound. So the first statement, both substances are compound. Statement 1 is wrong. Both substances are not compound. Diamond is an element because carbon atoms are there, all identical atoms are there, so we call element. If two or more different types of atoms, we call compound. So diamond is element, silicon 4 oxide is a compound. When you check option 2, there are strong covalent bond in diamond. So there are strong covalent bond in both diamond and silicon 4 oxide. So that this statement is true. Silicon 4 oxide is bonded ionically. That's wrong. It is a covalent bond and both substances have a very high melting point. So that is also true. So what is the right statement? 2 and 4 are the right statements. Is it clear? Silicon 4 oxide, the bonded is bonded ionically. It's not correct. It is a covalent bond. Covalent bond means the bond which is formed by sharing of electron. Because the electrons are shared, so we call this type of bonding as a covalent bond. And two non-metals are there. Two non-metals cannot have an ionic bond. They always have a covalent bond. Is it clear to everyone? Silicon, yes, Abdullah, that's right. In terms of position, silicon is a metalloid. The term metalloid means can have some properties resemble with metal and some properties resemble with non-metal. But in bonding, its properties resemble with a non-metal which tend to share electron instead of transfer electron. Three statements about the diamond, graphite and silicon 4 oxide are listed. Which statements are correct? Which statements are correct? A, B, C, or D? You can use screen annotation or you can use a chat to state the answer. So when we check, so A is the right answer. Why A is the right answer? When you check all the statements, the first statement, diamond and graphite both have a giant covalent structure. That's true. Silicon 4 oxide, silicon and oxygen atom are joined together by a covalent bond throughout the whole structure. Yeah, that's true because the structure is a macromolecule, but the bond between them is a covalent bond that is formed by sharing of electrons. So throughout the structure, silicon and oxygen are sharing the electron with each other, result in forming a macromolecule. So statement 2 is also correct. And diamond and silicon 4 oxide have a similar structure. That's also true. That's why 1, 2, and 3, all the three statements are correct. So A is the right answer. Is it clear? Another question. Which statement about the structure and property of silicon 4 oxide is not correct? Not correct. A, B, C, or D? The question is which is not correct. So statement B is not correct. B is the right answer. Look, when we check, the question is which statement about the structure and properties of silicon 4 oxide is not correct or not right. It has a giant structure similar to that of diamond. That is true. That is correct. It has high melting point due to strong attractive force between the molecule. There are no molecules in silicon 4 oxide because of giant structure. This state, it is having a high melting point. This is true, but not due to strong attractive forces between the molecule. That is due to the giant structure. So this statement is not correct. It will be correct if they write giant structure, but they did not write the giant structure. That's why it is not correct. There is a strong covalent bond. Covalent bond is always stronger, so that is correct. And there is no free electron in silicon 4 oxide. That's why it does not conduct electricity. So silicon 4 oxide does not have any free electron. That's why it cannot conduct electricity. So statement A, C, and D are the right statement. Statement B is not the right statement. That is why it is a answer. Is it clear? Why B is the right answer for this? Don't bother about, well, like when you mark the answer, maybe your answer might be wrong, But it's not an issue because it's a learning part. So you will learn from your mistakes and you will remember these things. Which statement about silicon 4 oxide or sand is correct? So now we have to find the correct statement. Silicon 4 oxide does not have any free electron. Graphite is a macromolecule which can conduct electricity. Silicon 4 oxide, sand. So which one is the right? It conducts electricity because it contains free electron. That is wrong. It cannot conduct electricity. It is macromolecule in which 4 oxygen atoms bonded with each silicon. That's true because one silicon bonded with 4 oxygen atom and then it will continue the structure. So that B is the right answer. Why not C? It is a simple covalent. No, it's not a simple covalent. It is a giant covalent structure or a macromolecule. And its structure is similar to graphite. No, it's not similar to graphite. It is similar to that of diamond. So that's why D is also not the right statement. The correct answer for this one is B. Is it clear why B is the right answer? Yeah, it does not have a molecular structure. It is having a giant structure. When we say something is a molecule, giant covalent molecule or giant covalent structure, we can say. Is it clear discussion that why B is the right answer for this? Then the last type of bonding is known as a metallic bonding. So what is basically a metallic bonding or a metal? This type of bonding exists within the metal or mixture of the metals. We also call them as alloys. So what happened in a metallic bonding? As we discussed in the first part, what is the tendency of the metal? The metal tends to lose electron. The general tendency of the metal, they always tend to lose electron. So if I say any metal is there, it's not like particular metal. If I say any metal M is there, okay, and this is the last shell of this metal. I'm drawing the last shell only. So what it did, it loses electron. So when this metal will lose electron, what will be the charge on this metal? What will be the charge on this metal ion when it loses electron? So it's good, that's +1, or I can say positive. And the electron is being lost. So the attraction between the positive ion, so it will form a positive ion, and there is electron. So this attraction, because unlike charges attract each other, so the attraction between the positive ion and the electron, what we call this attraction is having a specific name. We call that as a metallic bond. So attraction between the positive ion and the electron is known as metallic bond. So what happened? The metals, they have a tendency to lose electron. So when the metal will lose electron, so what they form, these metal, as they lose electron, they will form a positive ion. So there is a positive ion formed by a loss of electron, and the positive ion will try to attract the electron. The attraction between the positive ion and the electron is known as the metallic bonding. Is it clear? The idea of a metallic bonding? And what about the structure of the metal? So what about the structure of the metal? Example, if I say I have potassium, which belongs to group 1, I have potassium metal. So when this potassium will lose electron, so what will be the charge on this potassium? It will form a positive ion, and there will be electron and attraction between them. We call that as metallic bond. But this has happened for one potassium, but we have millions or trillions of potassium. So what will be the structure? There will be one potassium, then electron will be there, then another potassium, electron will be there, then potassium, electron, potassium, electron. And this will continue. So there will be a lot of potassium ions and the electron within the structure, because this is what happened for one. But you don't have one atom, you will have millions or trillions of atoms. So potassium ion will attract the electron, and there will be lot of potassium, and there will be lot of potassium ion and electron in the structure. So how we define this structure? We say we have a lattice of a positive ion. Lattice means regular arrangement. So lattice of positive ions and sea of electron. When we have lot of electrons, we use the term sea of electron. So what is the structure of a metal? A metal consists of a lattice of a positive ion, means arrangement of the positive ion, and there is a sea of electrons. There will be lot of electrons within the structure. Is it clear, the concept of structure of metal? This is example of potassium, but all the metals have the same structure. They have a lattice of a positive ion, and they have sea of electron. Same way, example, if you have iron. Yes, you can use a chat, or you can use your mic to ask your question or doubt. Okay, Abdullah, I will repeat. Yes, Vijay, any question? Look, what happened in a metallic structure? First, what is a metallic bond? Example, you have metal potassium, okay, which is having one electron in the last shell. When this potassium will lose electron, so when this potassium will lose electron, what will be the charge on this potassium? It will be +1, and that electron is being lost. So when this electron is being lost, this attraction between the positive ion and the electron, this is called a metallic bond. That is the first thing. Abdullah, is it clear? Abdullah Sarfraz, first part. The metallic bond. The metal loses electron, but there is an attraction between the metal positive ion and the electron, we call that as metallic bond. But what about the structure? Structure of the metal, look, you will have lot of potassium. You don't have one potassium, you will have millions or trillions of potassium atom in the structure. So when all of them are losing their electron, so when these potassium are losing the electron, then what will be the structure, how it appear? That when potassium will lose electron, the potassium will form a positive ion. This potassium will form a positive ion and there will be electron. Then the second potassium will form a positive ion and there will be electron. Then the third potassium will also loses electron, so form a positive ion and electron. Then this another potassium which is losing electron form a positive ion. So this will continue as all of the potassium loses electron. So when all of the potassium loses electron, what we call this structure in which we have a arrangement of a positive ion. So we say that metals have a lattice of, lattice means regular arrangement. So you have lattice of positive ion in sea of, you can say mobile electron because the electrons are moving. So you can say mobile electrons, or you can also say sea of electrons. Is it clear? The metallic structure. Any question or a doubt related to this part? So this is the structure for all the metals. So in exam, when they say draw the structure of a metal or draw a metallic structure, so for any metal, how you draw the structure? You will draw the positive ions should be very close to each other. So the positive ion is there. These all are positive ions. And I can write E here, electron. So that's why we call in a metal we have a positive ion in a sea of, a lattice of a positive ion in a sea of electron. Is it clear? The structure of any metal, because all the metal they have tendency to lose electron. So it's not like all will have plus one, but this plus is only representing the nature. It can be plus two, it can be plus three, it can be any number, but depending on, we don't have to show that. Yes, we can draw any number of electron and we can draw anywhere. That's right, because these electrons, even if you can shade this region, you can shade this region also, because these electrons are not a stationary electron, they are free to move, so you can even shade the region, that is also acceptable. So when we compare ionic and metallic structure, so when we are comparing the ionic structure with the metallic structure, basically what happened in ionic structure, you have metal and you have non-metal. Metal I'm representing by M and non-metal I'm representing by N. So metal will lose electron, non-metal will gain electron. So when the metal loses electron, metal will get a positive charge, and non-metal will gain electron, it will get a negative charge. And what is the structure? This is attraction between the positive and the negative ion, between the metal and non-metal ion. This attraction, we call that as ionic bond. And when we compare the structure of a metal with a non-metal, means ionic with metallic. So in ionic, what is the structure? We have two types of ions present in the structure. So the two ions which are present in the structure, one is a positive ion, negative, positive, negative, and so on. This is the ionic structure or structure of ionic compound. And how we explain this structure? We say that ionic compounds, they have a lattice of positive and negative ions, because they have both positive and negative ions arranged in a regular pattern or a manner. But when we say about the metallic, what happened in a metallic structure? So we have metal, and that metal has a tendency to lose electron. So when the metal has a tendency to lose electron, what it will form? It will form a positive ion, and there will be electron and attraction between them. What we call this attraction? We call this attraction as a metallic bond. And what about the structure? So in case of metals, what we have? We have all the positive ions are there, and the free electrons within the structure. So electrons are there, and there is a positive ion because of loss of electron. And this lattice, the explanation here, it is a lattice of positive ion in sea of electron. So that is the main difference between the structure of metals. Even a metal mixed with a metal, Abdullah, that's a good question. Even a metal mixed with metal, both metals have a tendency to lose electron. So it will be a similar structure. But only difference, like if a metal mixed with metal, as your question is, so we will show positive ions, but one will be a larger in size, another one like different positive ion. So we'll use different size for the positive ion, but the structure will be similar. Is it clear the comparison between the ionic and the metallic structure to everyone? So the last part is about the metallic bonding. You should be able to describe the metallic bonding as a lattice of a positive ion and in the sea of electron. And metals, the general properties of the metal, they can conduct electricity. Why the metals can conduct electricity? Because they have electron, free electron. And why the metals are malleable? The term malleable here refers to we can hammer them into shape. So why the metals are malleable? As you can see, there is a layer of a positive ion, like this is one layer, but these layers are very close to each other. This is one layer, this is a second layer, and this one is a third layer. So these layers can slide over each other, slip pass over each other. That's why the metals are malleable. Malleable means we can hammer them into shape. So example, this is an example question. Which statement describes the structure of copper? Keep in mind copper is a metal. So basically they're asking which statement explains the structure of metal. What could be the right answer? A, B, C or D? Yeah, C is the right answer because has a lattice of a positive ion in a sea of electrons. Which statement about the metal is correct? Yeah, that's good. The layer of positive ion can slide over each other. That's why they are malleable. Metallic bonding consists of lattice of negative ion. That's wrong. It is a lattice of positive ion. Metallic bonding consists of lattice of a positive ion in a sea of delocalized negative ion. That's wrong. It should not be negative ion. It should be electrons. And metal conduct electricity because of positive ion? No, because of free electrons. The structure of a copper is described as a lattice of a positive ion in a sea of electron. Delocate means you cannot identify the position, because if something is not having a specific position, it is free to move. We call that as delocalize. So which statements are correct? Copper has a high melting point because a strong electrostatic attraction between the positive ion and a sea of electron. That's true. Copper is malleable because a layer of atoms in the lattice can, not layers of atoms, a layer of positive ion. And copper atoms can oxidize. The term oxidize means can lose electron. When something lose electron, we call oxidize. So that's why statement 1 and 3 are the right. So C is the right answer. Is it clear? Any question related to metallic bonding? I'll share another link, and in that last session, it will be a short session. I will discuss the types of the bonding. That's the overview of what we have discussed. We'll discuss all the types together: ionic, covalent, simple and giant, as well as the metallic.